Welcome to the next video in the network series. This is video 2 on properties of networks. So properties of networks are, I guess you could say, features of them that affect their performance. You know, some networks have these properties, others don't. So I guess here the point of this is that one property that we might be interested in for networks is the number of nodes that they have and the number of edges. And here I think the point is that, what's the word science doing in the course title Network Science? Well, we are, after all, interested in understanding things, but that's not all that science is. Science is pretty much fundamentally a predictive practice, right? So we want to be able to understand the properties of networks and then use that to predict real-world phenomenon, like by saying, if a network has a given property, then it's going to tend to behave like this or that. And then this is also kind of relevant to engineering because we'll want to solve optimization problems. And I suppose these are some examples of particular applications or fields of applications that we may want to apply these ideas to. So we've already listed a number of examples. And one thing that's kind of interesting is to look for emergent phenomenon. So emergent phenomena are features which may seem invisible at the microscopic level, right? If you were really looking at the details of, say, this particular computer or this node in whatever network, if you were, learning a lot about the details of any one individual, then you may not see bigger, broader patterns of how this individual or how all of the individuals within a network tend to exhibit tendencies and behaviors which could not easily be seen at the individual level. I think maybe a good metaphor is in this picture right here, where if you were investigating any one of these birds in the sky, and maybe even looking at its movement and so on, you wouldn't notice these sort of clusters of birds moving together. And they often, right, like we've all seen birds moving together in a flock like this, the entire flock seems to almost move together as if it were a single sort of organized body. And that would be an example of an emergent phenomenon, right? Something that is hard to detect at the small scale, but when you look at how all of these things are sort of interacting as a large group, you start to notice broader patterns. So that's emergent phenomena. And so I guess the suggestion here is that another kind of example of emergent phenomena is like tying strings on a board to look for connections between pieces of evidence or information or whatever. Maybe the connections themselves and the distribution of the connections can help you to detect something you wouldn't see if you were looking at much more granular information. And here we're looking at various applications of all of these sorts of ideas. So again, kind of focusing on the important essentials here, the definition of a complex system, I guess, would just be any, I suppose, network with a large number of nodes and edges. Perhaps maybe that's a complex network, a complex system might be some bigger, broader description. Like what is a system? I suppose it is things that are maybe not just connected by edges, but by more descriptive interactions between components. And then emergent property, which we just talked about. We know a bunch of examples of complex networks. And we flip through a bunch of applications about how we might make life better by analyzing them and improving the performance of our networks. So what are some important things that we'll get out of studying in this class? We'll learn a bunch of vocabulary. Yeah, I guess that is pretty valuable. we'll actually get hands-on experience with some network tools. I know I looked briefly at the practicum portion of this course, and there's a whole bunch of stuff using like a bioinformatics, sort of like network tool. So that's maybe interesting. I know nothing about bioinformatics, but we'll see how that goes. And we'll learn how to quantify network properties. We'll learn various algorithms that can be implemented on networks. Find important nodes and communities, which sounds maybe, I'm not sure how that's any different from properties, right? Because a community would basically be some kind of like a property of a network. But anyway. And start to think, right, like we typically think of networks as these static things, which are, nodes and edges, and they just have these connections, but they really are mostly dynamic processes, so that those edges are really flow of fluid through pipes or information through information networks or so on. So, it'll be a little bit beyond just the static picture to then start thinking about the dynamism of these networks as things evolve over time. So as we've said, we'll have theory sessions and practice sessions. I guess we'll be working in Python, a little surprising, but okay. We'll need to know probability. Well, that's fantastic because I have a playlist that is on discrete mathematics and another one on measure theory and relatedly probability theory. I think that would be way overkill for what we need here. But anyway. So I guess that's the end, and I think I'll have to look into what comes next. Do I look at the next set of slides, or do we jump into the practicum? Probably I'll just see how much of the practicum we can get done, and that'll perhaps be the content of the next video.